Hello viewers, in this video I want to briefly touch on what is called ANOVA. ANOVA simply means analysis of variance. And what is it used for? ANOVA is used to evaluate the statistical mean of at least 3 groups to determine if there is a significant difference in the output of the groups. So going by the definition, we say that ANOVA is analysis of variance. On the screen, you can see the formula for variance. And what is variance? Variance is just a measure of the spread of data in a given data set. Now, if you look at this formula for variance, and here is our formula for our standard deviation. If you could remember from my previous videos, you will see that the only difference between these two formulas is that the formula for standard deviation contains a square root sign, while that of a variance does not contain a square root sign. So as we work an example, you are going to see how this is used. Let's assume a researcher is carrying out an experiment and you gather data from 3 different groups. This is group 1, this is group 2, this is group 3. If you want to evaluate the statistical mean of these 3 groups to see if there is any significant difference, the kind of test you are going to use is ANOVA. By the way, ANOVA is an extension of the Z and T test that we mentioned in my previous videos. So the first thing you do when you are given a problem like that is to state the null and the alternate hypothesis. And here is how we state both hypotheses. So the null hypothesis says mu1 equals mu2 equals mu3. While the alternate hypothesis say mu1 is not equals mu2 and that's not equals mu3. Remember, we mentioned that ANOVA is used to analyze if there is any difference between the mean of at least 3 groups. So for these 3 groups, this is the null hypothesis, which states that there is no difference. That's mu1 equals mu2 equals mu3. While the alternate hypothesis is saying that at least one of the groups has a mean statistically different and is usually evaluated at an alpha value. Alpha means the significance value. So at an alpha value of 0.05, 0.01, 0.1 as the case may be, but the most popular is 0.05. The step 2 is to analyze the degree of freedom. We are going to have 2 different degrees of freedom. So this is degree of freedom between, and this is the degree of freedom within. Between the groups, in this case, the degree of freedom between the groups and the degree of freedom within each group. So for the degree of freedom between, it is called K, and it's usually n minus 1. N here stands for the number of groups. And our groups, we have 3, so 3 minus 1, that will give us 2. So the degree of freedom between is 2. While the degree of freedom within, given by n minus k minus 1. N is the total number of samples in all of the groups. So for the 3 groups, each of the groups has 3 samples, as you can see. So that makes a total number of 9 samples. Minus our k is 3 minus 1, which equals 6. The next step will be to calculate the F critical value, and it's given by the formula the degree of freedom between all over the degree of freedom within. So our degree of freedom between, as we noted earlier, was 2, while our degree of freedom within was 6. So what we do is that we read it off what is called the F distribution table at alpha equals 0.05. This 2 you will read from the horizontal part of the table, while the 6 you will read from the vertical part of the table. So we have 2, you read it up to 6. So that's our F critical value, giving us 5.14. So now let's calculate the sum and the mean of each group. So the sum for the group 1 is 7, sum for group 2, 10, and sum for group 3, 8. Now the mean for group 1, that means everything divided by 3. That is the sum rather divided by 3. So the mean for group 2, for group 1 is 2.33. The mean for group 2 is 3.33, while the mean, for group 3 is 2.67. With this, we will now calculate what is known as the grand mean. The grand mean is simply the total sum all over the total number of samples. And as we can see, the total number of samples is 9, 3 for each group. And if you do that, the grand mean would give you, I'll call it X, big X bar. The grand mean is 2.78. So here it is again. The grand mean is the sum of all the samples all over the total number of samples. That will give you 25 over 9, which is 2.78. For the next step, we're going to calculate the sum of squares. The sum of squares total, and then the sum of squares within. So we'll take that for each of the groups. The sum of squares total will be, you take for each of the groups 2 minus the grand mean, 2.78, and then you square it, plus 1 minus 2.78, and then you square it, plus this is 4 minus 2.78, and then you square it. You come to group 2, plus 3 minus 2.78, square it. I'm coming to group 3 now. 1 minus 2.78, you square it. And finally 4 minus 2.78, and then you square it. If you do all of this meticulously, you will see that the sum of squares total will give you 15.56. So this is an important result. The next will be the sum of squares within. And for this, we are going to, for each group, remember that the mean for this group is 2.33. So for each group, we evaluate this formula. We'll now have for this group, sum of squares within will now be for group 1, 2 minus, what's the mean for that group? 2.33. You square it, plus 1 minus 2.33, you square it, plus 4 minus 2.33, you square it. Then you come to group 2, plus 3 minus the mean of group 2 is 3.33, you square it. Then I come to group 3. We'll now have 1 minus the mean of group 3 is 2.67. And Finally, for group 3, I have 4 minus 2.67, rather. This was wrong. Now squared. So, if you do all of that, sum of squares within will give you 14.0. So now we want to calculate the sum of squares between. The sum of squares between is sum of squares total minus sum of squares within. So sum of squares total, we got 15.56 minus within, we got 14.0. So that gives us our sum of squares between to be 1.56. The next step is to calculate the variance between and within. So this is given by this formula. Variance between is sum of squares between. And what was our sum of squares between? We just calculated it. It's 1.56 all over the degree of freedom between. If you could remember, when we calculated that, it was 2. So variance between will be 1.56 over 2. So that gives us 0.78. And then our variance within is sum of squares within all over degree of freedom within. Our sum of squares within was 14.0 all over degree of freedom within. When we calculated it, it was 6. Remember? So that gives us 2.33. Guys, we're almost there. The next step now is to calculate the F statistics, or F calculated, and it's given by the variance between and the variance within. From our last step, the variance between was 0.78 all over the variance within. We just calculated that 2.33. So guys, punch your calculator. 0.78 all over 2.33. That gives me 0.33 to 2 decimal places. And remember, earlier on when we calculated the critical F value from the table, we got 5.14. So the conclusion that we are drawing from here is that the F calculated 0.33 is less than the critical F value. And if that be the case, we fail to reject the null hypothesis. If your calculated F value is less than your critical F value, you fail to reject H naught. Meaning we are going back to our original H naught, that mu1 equals mu2 equals mu3, meaning there is no significant statistical difference between the mean of the 3 groups. Guys, I hope this was simple enough. Please share this video. Kindly comment on this video. If you've not been following, kindly follow my page for more. Thanks and bye for now.